and it was not Uniden, it were someone's own wiring, and he didn't even bother putting any isolation caps or chokes or whatever down here. He never bothered. Anyway, I put it back to normal so that my Stalker 9 mic works back on it now again as normal. I've checked its TXAF stages and it's all up and running, and I've done everything now as far as I know. I've even had a look on the scope to see if there's any preamp TX being made, and there is. Jumping for joy, it's really ready now for its final. But do you remember when I said to you that the carrier balance is turned right fully to one side? Can you see that there? Right turned up. Well, when I come to set the TX final bias, that is going to cause a problem. You see, folks, right, everything has to be done in its order. For example, you know, or some of you know, that for me to set the TX bias up correctly, what you've got to do theoretically is to put the transmitter in TX idle stage, what they call TX idle. In other words, you're telling the TX final transistors to turn on, but you're not allowing any RF to go in. It's a special way of testing. First of all, what you do is you put a dummy mic plug on with just a PTT. It's got 3 wires used today because Stalker 9 FDX has a receive, right? So, and the reason for that is we don't have any mic audio going to the socket, you see. No need for any generators or anything in this stage. We're just going to tell that transmitter when it gets going just to what they call turn on and get ready for amplifying RF, but don't amplify any RF. But hey, the carrier balance is going to cause me a problem, you see, because as you know, TX idling wants to be done in SSB. If I were to try and get TX idle in AM or FM, it'd be impossible, because radio would always be making carrier, even if the carrier adjustment would turn to its lowest, which is at the highest now, but it makes no difference. You'd never get it. It's always producing carrier, you see. So that's why they tell you to put it in SSB mode, no mic gain, or in my case, no mic at all, and just turn transmitter on, put it in TX, and then you set your idling current for your both finals, driver and final. But if my carrier is producing some my carrier nulling system is producing some carrier, that's going to cause a problem, folks, because you're putting RF straight through the stage while you're trying to get it to idle. You can't get it to idle while it's doing RF, so we must stop it from doing RF, okay? So what I've done here is I've just connected my oscilloscope there. That's it's just for you for the video. That wire is connected directly to buffer stage output, right? And so that now when I put my dummy switch on, I'll just put the radio to SSB, right? Radio's a little bit of static, look. Radio's in SSB now, and when I press the radio into TX, look what happens. Can you see that? Oh, I bet you loads of you are thinking, that's good, it's producing RF. It is, but it shouldn't be. I'm in USB. There's no microphone connected, and that's because the carrier balance is turned full up. Watch what happens when I put my blowtorch screwdriver in the carrier balance adjustment, and I'll turn it while I'm talking to you. Goodbye, carrier, goodbye, goodbye, goodbye. All the best, see you later, and goodbye. Just turn my amplifier up on scope a bit here, just so I can see if I can null it completely before I get my PA script running. That's about best I'm going to get it, okay? So next stage now, right, is I will now go ahead and put the finals in. See where the balance adjustments ended up, roughly middle. Okay, but now I know that now going into normal scope type mode. You can just see it switch there, look. That's excellent. But when I tell it to go to FM, oh, slow boy. That's just what I want, folks. Right, so now I'll put the output stage in. Let's just put my Stalker 9 mic on and just check that that works. Doing it all on one hand, eh? Marvellous, that. How do you do that? Paul. How you doing, Paul? Can't talk to you right now, Paul. I don't have a transmitter stage. Well, the finals. By the way, Americans, that's the difference what you get if the front were lifted off. If that were removed to get it into our country, they put that on it, and they didn't tell them it had AM and sideband. They didn't tell them. I lied. See you in a bit, lads. Hi folks again, this is me, of course, and this is the last sitting tonight. I've done all the chores today, on and off, and every time that you've seen me work the video up, it's when I get a chance to come in. That's how it is. My mate Paul. Anyway, like I say, I'll put transit in. You can see bias boards in now, and now it's on that 10 amp Watson power supply, and we'll see if it transmits. We'll see if it transmits. As you can see, it goes to TX. Doesn't draw any current. Let's have a look at that bias board. 3 volts. 3 volts and carrier power turned full up. Oh, there's something wrong there. Just hang on a minute. Okay, I'm back again, folks. I've just tied it high now directly. Now, can I have a lamp in here, please? Okay, so you can see that now, and I'm driving this now. That's just a multimeter, and it's connected straight to that, right? And when I key the mic, you can see it drops to 0 virtually, as we call it 0. I've seen that before many a time. It's what we call collapsing. Now then, what's going wrong then? What's going on? Well, I'll tell you what's going on. There's 3 pins here, right? And you all know that that's the bias board. You take it out for putting your multimeter in the middle. The multimeter in the middle for the driver, for the final and the driver, and individually then you're looking at current demand from each different device. Now in this case, folks, what's happening is the first pin here is what we call the source supply. He goes to the regulator, and the regulator feeds the supply to this lot, 13.8 volts roughly. Then the other 2 pins supply the 2 finals. What's happening in this case, the reason why we're not transmitting, I believe, is because that lot's collapsing. It's collapsing. And I've just had a look at the voltage in to that regulator, and it's got its supply there all the time. But when I look at the output, in fact the base, I think it's the base and the emitter in this case, right, what's happening is they both sit at exactly the same voltage. That's not correct. And I'm not sure what's wrong in there, but there's something wrong in there, whether it be the 2SA1012 or the 2SB525C or something else in that area. But the modulator and regulator stage is broke down. It's a shame, because I want to talk to my mate Paul. Him. So what I'm going to do, just for you on the video, I'm going to individually power this animal up. I know that when it's on full power, it should be anywhere on the collector supply of anywhere between 6 and 8 volts here in AM and FM, and about 13-14 volts in SSB. So let's just see what happens when it goes to SSB. Okay, sideband, it goes to less than half a volt, just a bit more than half a volt. FM, it goes back to 3. It should go to 14 volt in SSB, and about anywhere between 5 and 8 volts or something in AM and FM. So it wouldn't transmit, folks. As soon as I keep my look, watch, just drops to 0. In other words, as soon as that gets any hard work, it just collapses. So I'm going to tie it high with my variable power supply. I'm going to have that running the radio, and I'm going to have that running the PA strip. Stand by.